Hi guys, in today's video we'll be solving sums to find the derivatives of composite functions. So what do we mean by a composite function? So when there are two or more functions included one within the other, then such a type is called a composite function. Now functions we can have of any type, so that will be log x, sin x, cos x, tan x, e raised to x, x square, x cube and so on. So when we say e raised to x, we know its derivative is e raised to x itself. Now suppose in place of x we have x square. So our question is e raised to x square. Now this becomes a composite function because e raised to x is a standard function and x square also is a function. So our outer function, we'll call it as f1, which will be e raised to x, and f2 will be x square, which is the inner function. So the formula for finding the derivative of such functions will be derivative of f1 into the derivative of the other function f2. So therefore we'll have derivative of e raised to x square as e raised to x square into derivative of x square, which is 2x. So our final answer will be 2x into e raised to x. Similarly, suppose we have log of cos x. So here f1 would be log of cos x, and f2 would be cos x. Now to find the derivative of f1, that is derivative of log x, we know its derivative is 1 upon x. Now because we don't have log x, we have log of cos x, so we'll replace x by cos x. So our derivative of f1 will be 1 upon cos x into derivative of f2. So that is derivative of cos x we know is minus sin x. So the answer will be 1 upon cos x into minus sin x. Now we know that sin x upon cos x is cot x. So our answer would be minus cot x. So let's look at some examples now. You can also check out my earlier videos on derivatives where I have explained the formulas for the standard derivative functions, as well as I have discussed the different rules which are used in derivatives, that is the derivative of sum rule, product rule, difference rule and so on. The links for these videos would be in the description box below. Let's look at our first question. We have sin 3x plus 4. Now here our outer function, that is f1, will be sin 3x plus 4, and then we have another function of x which is 3x plus 4, that will be f2. So to find dy by dx, we will first find the derivative of f1 and then multiply it with the derivative of f2. Now the derivative of sin x is cos x, as we know. Now in this example, just in place of x we have 3x plus 4. So first we will write cos 3x plus 4, that will be the derivative of f1 into derivative of 3x plus 4. In 3x plus 4, since two terms are being added, to find their derivative we'll use the derivative of sum rule. So that gives us cos 3x plus 4 as it is into derivative of 3x plus derivative of 4. So that further becomes cos 3x plus 4 into 3 plus 0. So the final derivative of sin 3x plus 4 is 3 into cos 3x plus 4. Now our next question is log of x square plus 2x plus 5. So here again the outer function, that is f1, will be log and f2 will be x square plus 2x plus 5. Now the derivative of log x is 1 by x, but again here in place of x we have the whole term x square plus 2x plus 5. So derivative of log will be 1 upon x square plus 2x plus 5 into derivative of x square plus 2x plus 5. Now again, since the terms are being added using derivative of sum rule, we get it as 1 upon x square plus 2x plus 5 into derivative of x square plus derivative of 2x plus derivative of 5. Now if we substitute the formulas of the standard functions, we will be left with 2x plus 2 in the bracket. Now if we remove 2 common from the numerator, that will give us the answer as 2 into x plus 1 upon x square plus 2x plus 5. Let's now look at an exponential function. So our outer function here will be e raised to 3 sec x plus 4 tan x, and inner function will be 3 sec x plus 4 tan x. So our first step would be derivative of f1, which would remain the same since the derivative of e raised to x is e raised to x itself, then multiplied with derivative of f2. So solving that further, we are left with e raised to 3 sec x plus 4 tan x into 3 sec x tan x plus 4 sec square x. So we can write sec x as common and then we'll have our final answer as follows. In our next example, we have x square plus 1 the whole bracket raised to 5. Now here the whole bracket raised to 5 will be f1 and the terms inside the bracket which are x square plus 1 will be f2. Now to find the derivative of f1, it would be similar to finding the derivative of x raised to n, which is n into x raised to n minus 1. Now in this example our n is 5 and in place of x we have x square plus 1. So the derivative will be 5 into x square plus 1 raised to 5 minus 1 into the derivative of x square plus 1. So next step would be 5 into x square plus 1 raised to 4 into derivative of x square plus derivative of 1. Now derivative of x square as we know is 2x and derivative of 1 is 0. So when we open the bracket and multiply, we'll have the answer as 10x into x square plus 1 the whole raised to 4. Next question is a bit different. So we'll have to apply two formulas because two things are happening. One is two terms are being multiplied which are e raised to 7x and cos 7x, and also both terms individually are composite functions. So to begin with, first we'll apply the derivative of product rule. So that will be first term which is e raised to 7x into derivative of second term which is cos 7x plus cos 7x into derivative of first term which is e raised to 7x. So let's solve each term separately. So to find the derivative of cos 7x, outer function now here would be cos and the inner function f2 will be 7x. So let's keep e raised to 7x as it is because it is not in the derivative. So our next step will be e raised to 7x into derivative of cos which is minus sin 7x into derivative of 7x. So that will give us e raised to 7x into minus sin 7x into 7. So let this be our first equation. Similarly, let's solve the other term. So here f1 is e raised to 7x and f2 is 7x. So again cos 7x will be as it is multiplied by derivative of f1 which would remain the same because it is an exponential function and the derivative of such a function remains the same into derivative of 7x. So our equation 2 becomes cos 7x into e raised to 7x into 7. Now to get our final derivative, we add these two equations. So that will be 7 e raised to 7x into minus sin 7x plus 7 cos 7x into e raised to 7x. So taking 7 e raised to 7x common, our answer is 7 e raised to 7x into cos 7x minus sin 7x. In this question again, just like the previous one, there are two terms x and sin 2x which are being multiplied, but now they are within another function that is of log. So this will become a composite function as well. So f1 is log of the entire bracket and f2 is the inner function which is x into sin 2x. But unlike the previous question, here first we'll apply the formula of derivative of composite functions. So that will be derivative of f1 which would be similar to derivative of log x, but here in place of x you have x into sin 2x. So derivative of f1 will be 1 upon x into sin 2x into derivative of x into sin 2x. Now because x into sin 2x has two terms which are multiplied, we'll apply the derivative of product rule. So let us first calculate that separately. So derivative of x sin 2x will be x into derivative of sin 2x plus sin 2x into derivative of x. Now again sin 2x would be a composite function. So the derivative would be x into cos 2x into derivative of 2x plus sin 2x into 1. Now our equation 2 becomes x into cos 2x into 2 plus sin 2x. So if we substitute equation 2 in equation 1, our final derivative would be as stated below. Now in our last question, we have e raised to root cos x. So again here f1 is e raised to root cos x and f2 is root of cos x. So the derivative would be first the derivative of f1. Now because we have an exponential function, the derivative would remain the same. So it will be e raised to root cos x into derivative of root cos x. In root cos x again we have two functions. So let us say that f3 is root cos x and f4 will be cos x. So e raised to root cos x first will remain as it is. Now in place of derivative of root cos x, first will be derivative of f3. So derivative of root cos x would be similar to derivative of root x, which is 1 upon 2 root x. But in place of root x, we will be writing it as root of cos x. So we have 1 upon 2 into root cos x into derivative of f4 that is cos x. Now derivative of cos x as we know is minus sin x. So our final answer is minus sin x into e raised to root cos x upon 2 into root cos x. Okay guys, thank you for watching. Hope this video was helpful.